Hey boys and girls, Mr. Giomini, coming with two questions from the OAA assessment from previous years. Just a little bit of review. Um, Take a look at this first one here. I'm going to kind of use the same strategy we've been talking about for the past couple days. Let's take a look at the first one here. First time I was going to read through the question. Really read it, see if I can make sense of it. Next time I'll go through and kind of deconstruct it as we've been talking about. So a pattern is shown. 1, 4, 13, 40, 121. In your answer document, describe the rule for the pattern and find the next term. Show how you found the next term in the pattern. I see over here that this is a 2-point question. So, I'm going to go back, and now that I've read it, I'm going to kind of pull it apart, deconstruct it, and really analyze it a little bit more closely, box in some verbs, underline what the verbs tell me to do. So a pattern is shown. Now, here's my pattern right here. 1, 4, 13, 40, 121. First thing I notice is they're all getting bigger. So typically to make numbers bigger, I would do one of two operations. Now remember, you can do these same things on a test. I would either do some addition or I would do some multiplication, or maybe a combination of both. In your answer document, describe. I'm going to just box in that verb. Describe. What must I describe? The rule. The rule. Oh, where'd my pen go here? Uh-oh, something's not responding. There you go. The rule for the pattern, and find, there's my next verb, find the next term. And I must show how I found the next term. Okay, so describe the rule. So I'm going to rewrite the numbers down here. 1, 4, 13, 40, 121. Well, the first thing I think about is addition. Well, 1 plus 3 would give me 4. But if it's a pattern and we're doing the same thing all the time, well, 4 plus 3 does not give me 13. So I know it's not just adding 3. So that's not going to work. I also know that, well, 1 times 4 is 4. So if I multiply by 4, I get 4. If I multiply this by 4, I get 16 and not 13. Okay, so it's not just straight multiplication. So it must be a combination of both addition and multiplication. Well, what can I multiply by 1 to get close to 4? Well, if I multiply 1 by 3, I get 3. And then if I add 1 to that, let me change that there. If I then add 1, I will get 4. Okay, so let's see if I write that. So I take the value, which I don't know, so we'll call it a variable. We'll call our value v for variable. So if I multiply that variable by 3, or that term by 3, and then I add 1 to it, I will hopefully get the next term. So let's try that. Let's substitute in the 1 here. So you go 3 times, the term is, 3 times 1, because we're multiplying by 3, plus 1. So 3 times 1 is 3. Plus 1 equals 4. Hey, look, that's the next term. Well, let's try this same thing. So we're going to multiply whatever the term is. So we're going to multiply everything we're multiplying by 3. So we're 3 times, what's the next term in the sequence here, the pattern? 4. So let's try it. 3 times 4. Whatever I get in that product, I'll add 1 to that. 3 times 4 is 12. 12 plus 1 equals 13. Hey, look, that checks right here. Let's try 13. So whatever the value is, so value is 13. I'm going to times 13 by what again? I'm going to times 13 by 3. 13 times 3, if I don't know that, I go off to the side here. 13 times 3. I go 3 times 3 is 9. 1 times 3 is 3. That's 39, but 39 plus 1 gives me 40. Hey, I love it. Okay, next one. I'm going to multiply something by 3, whatever the term is. Well, the term in this case is 40. I go 3 times 40. Well, 3 times 0 is 0. 3 times 4 is 12. So I have 120, plus the 1. That'll give me 121. All right, now, describe the rule. Okay, well, let me describe this for them. And I might make 2 boxes for this, actually. I'm going to break this down to 2 boxes. One, I have my pattern. I'm just showing it, and here's my description. So let's describe over here. I'm going to type. You would actually write the rule for the pattern is to take the term, or the number we'll say, in the pattern, multiply it by 3, and then add 1 to the product to get the next number in the pattern. Alright, so if I take a look, I go back into my directions. Did I describe the rule? Sure did. I'm going to put a check there. Okay, describe the rule of the pattern and find the next term. I did not find the next term yet. I've ended at 121. So to find the next term, I will have to take 3 times, well, that term, that value there is 121, and then I will add, at 121, and then I'll add 1 to that product to get my next one. So I go 121, I could do it to the side here, times 3. 3 times 1 is 3. 3 times 2 is 6. 3 times 1 is 3. I then add, cannot forget to add that 1, so plus 1. The next term will be 364. I may even circle this, so whoever's scoring this, it draws their attention to that. Okay, let's take a look at that one more. Kate, I'm going to read it first, and then I'll go back and kind of deconstruct it. Kate drew a triangular flag in the coordinate plane as shown. There's Kate's triangular flag. Kate then reflected the flag over the x-axis. In your answer document, give the coordinates of the 3 vertices of the triangle and the coordinates of the endpoint of the new flag after it has been reflected over the y-axis. Alright, a lot of stuff here. Let's take a look. Kate drew a triangular flag in the coordinate plane as shown. Okay, there is Kate's flag. I'm going to circle that so I see where it's at. Kate then reflected the flag over the x-axis. Well, they did me a favor here. They've labeled x-axis, y-axis. Well, the y-axis is going north and south. If I were to reflect it over the y-axis, it would somehow end up over here. I don't want it here. I want it over the x-axis. Means it has to be down here somewhere. In your answer document, give the coordinates of the 3. So give is the verb. What must I give? The coordinates of the 3 vertices of the triangle and the coordinates of the endpoint of the new flag after it has been reflected. So there's my verb, reflected over what? The x-axis. Okay, so if I take a look, whenever I reflect over the x-axis, the x value, so I always have an x and a y value. So I always have an x and a y. Now if I look at point P, let's look at point P. Point P right now is at, start at my origin, 1, 2, 2 on the x, 2 on the y. So it is at 2, 2. If I reflect P over, reflected over the x-axis, it's still going to be 2 away from the x-axis. So it'll still be here. And it'll be also 2 away from the y-axis. So actually, it is right here. So I will call this P image. And P image is at, and I might just put the coordinates right there. Well, actually, they may not want that. They've said to list it. So I'll put P image is at, and let's see, maybe I should put that image below. P image is at still 2, but the y value is at its opposite now. It's at -2. Let's look at the next value, O. So we'll reflect O. Well, O originally was at 2, 3. 2, 3. If you notice something here, when I'm reflecting over that x-axis, the P value stays the same. It is the y value that becomes the opposite. And I see here that P and O are 1 apart, so they'll be 1 apart here. So O is at 2 again, same as this, 2, but now instead of being +3, it's -3. I go to the N, which looks like it's 1, 2 away from the O, so I'll just go, instead of going up 2, because that's getting closer to the x-axis, we notice that N is further away from the x-axis, so I'll go down to 1, 2. N up here was at, let's see here, well, along that 2 again, 2, 5. Well, when we reflect over the x-axis, it is the y value that becomes the opposite. The x value stays the same, so the x is still 2 for an image. And that is, let's see here, we said 2, and instead of being +5, it is now -5. And finally, I'll go with the M, because I must put all the points on there. M is at, well, here's the origin, it's at 0, 4. So M is at 0, 4 here. 0 being the x. So my new m, my m image, would be at x value stays the same when I reflect over the x-axis. It is the y that comes opposite, so the y would be -4. So we're at 0, -4, which would be right there. I'll connect my flag. And that, I'm sorry, that is not O, that is M. That is M. Okay, and that is O, 0, -5. Now, I should double check, and I didn't do this last problem, I need to do that. Go back and read the question again, make sure my answer makes sense and that I answer all the parts. Kate drew a triangular flag in the coordinate plane as shown. Notice I'm doing point and say. Kate then reflected the flag over the x-axis. In your answer document, give the coordinates of the 3 vertices of the triangle. Let's see, the triangle's vertices are NOM. NOM, I gave those. And the coordinates of the endpoint. The endpoint is P. I gave P. After the flag has been reflected over the x-axis, I did indeed reflect over the x-axis. So double check here. P was at 2, 2. If I reflect over the x, the y value becomes the opposite, so that'd be 2, -2. Check. O is at 2, 3 at the original image. The new image should be 2, -3 because reflecting over the x-axis, which I have 2, -3. Check. The n was originally at 2, 5. The new one should be the opposite of that y, so it's now 2. The x value stays the same, 2, -5. We're at 2, -5. Check. And my other point of my triangle, the other vertex of my triangle, which was M, was originally at 0, 4, as I have. If I reflect it over the x-axis, it'll now be at 0, -4. Check. I feel very confident in this, and I will stop and go on to my next question. All right. Have a great day. Take care. Bye.